Water is essential for life. We drink it, cook with it, and use it to clean. Water covers over 70% of the Earth's surface. It exists in rivers, lakes, and oceans. Water is also found in the air as water vapor. Water is a simple molecule made of 2 hydrogen atoms and 1 oxygen atom, H2O. Despite its simple structure, water has unique properties. These properties make it crucial for life on Earth. One key property of water is its ability to dissolve many substances. This ability makes water a powerful solvent. In fact, water is often called the universal solvent. This essay will explore the amazing properties of water. We'll learn about solutions, suspensions, and colloids. We'll also discover the difference between hard and soft water. Get ready to dive into the fascinating world of water. Water is called the universal solvent because it can dissolve more substances than any other liquid. This remarkable ability is due to the unique structure of the water molecule. The oxygen atom in a water molecule attracts electrons more strongly than the hydrogen atoms. This unequal sharing of electrons creates a polar molecule. This means the water molecule has a slightly positive end and a slightly negative end. The positive end of one water molecule is attracted to the negative end of another water molecule. This attraction forms a weak bond called a hydrogen bond. These bonds are responsible for many of water's unique properties. When a substance dissolves in water, the water molecules surround the individual particles of the substance. The positive and negative ends of the water molecules attract the oppositely charged parts of the dissolving substance. This process breaks the substance apart and distributes it evenly throughout the water. Water's ability to dissolve so many substances makes it essential for life. It allows nutrients to dissolve in the soil and be absorbed by plants. It also helps transport nutrients and oxygen throughout our bodies. When a substance dissolves in water, it forms a homogeneous mixture called a solution. In a solution, the dissolved substance is evenly distributed throughout the water. The dissolved substance is called the solute, and the substance in which it dissolves is called the solvent. For example, when you stir sugar into water, the sugar dissolves and forms a sugar solution. In this case, sugar is the solute and water is the solvent. The resulting sugar solution is homogeneous, meaning it has the same composition throughout. Solutions are all around us. The air we breathe is a solution of gases, primarily nitrogen and oxygen. Ocean water is a solution of salt and other minerals dissolved in water. Even the beverages we drink, like juice and soda, are solutions. Understanding solutions is essential in many fields, including chemistry, biology, and medicine. For example, knowing how substances dissolve in water is crucial for developing medicines that can be easily absorbed by the body. While solutions are homogeneous mixtures, not all mixtures involving water are solutions. Some mixtures, like sand in water, are heterogeneous. This means the components do not mix evenly and can be easily separated. A suspension is a heterogeneous mixture where the particles are large enough to be seen with the naked eye. The particles in a suspension will settle out over time due to gravity. For example, muddy water is a suspension because the soil particles will eventually settle to the bottom, leaving clear water above. Colloids are another type of mixture that falls between solutions and suspensions. In a colloid, the particles are smaller than those in a suspension but larger than those in a solution. The particles in a colloid are evenly distributed and do not settle out over time. Milk is a good example of a colloid. It contains tiny droplets of fat and protein dispersed throughout the water, giving it a cloudy appearance. Understanding the differences between solutions, suspensions, and colloids is important in various applications. For example, in the food industry, controlling the size of particles in a colloid can affect the texture and stability of products like mayonnaise and ice cream. Section 5. Saturated, unsaturated, and supersaturated solutions. Not all solutions are created equal. The amount of solute that can dissolve in a solvent can vary depending on factors like temperature and pressure. A saturated solution contains the maximum amount of solute dissolved in a solvent at a given temperature. For example, if you keep adding sugar to water at room temperature, eventually no more sugar will dissolve. At this point, the solution is saturated. An unsaturated solution contains less than the maximum amount of solute that can dissolve in a solvent. If you take a saturated sugar solution and add more water, the solution becomes unsaturated because there is now more room for sugar to dissolve. Interestingly, it's also possible to create a supersaturated solution. This type of solution contains more solute than it should be able to hold at a given temperature. Supersaturated solutions are unstable and can be easily disturbed, causing the excess solute to crystallize out of the solution. Understanding the concept of saturation is important in various applications, such as in the pharmaceutical industry. Controlling the saturation of solutions is crucial for ensuring the proper dosage and effectiveness of medications. Section 6. Water of crystallization, hidden water. Water plays a surprising role in the structure of some crystals. Water of crystallization, also known as water of hydration, refers to water molecules that are chemically incorporated into the crystal structure of a substance. These water molecules are not chemically bonded to the substance itself, but are trapped within the crystal lattice. The presence of water of crystallization can significantly affect the physical properties of a substance, such as its color, shape, and solubility. For example, copper 2 sulfate pentahydrate, QSO4, 5H2O, is a blue crystalline solid. The pentahydrate part of the name indicates that there are 5 water molecules associated with each copper 2 sulfate unit. When heated, the blue crystals lose their water of crystallization and turn into a white powder, anhydrous copper D2 sulfate, QSO4. Water of crystallization is essential in various industrial and scientific applications. In the pharmaceutical industry, for example, controlling the water content in drug formulations is crucial for ensuring their stability and effectiveness. Section 7. Metals and water, a reactive mix. Metals exhibit a wide range of reactivity with water. Some metals react vigorously with water, while others show little or no reaction. The reactivity of a metal with water depends on its position in the reactivity series. Metals like potassium and sodium react violently with cold water, producing metal hydroxide and hydrogen gas. This reaction is highly exothermic, releasing significant heat. The heat often ignites the hydrogen gas, resulting in a flame. Less reactive metals like magnesium react slowly with cold water but readily with steam. Metals like gold and platinum do not react with water at all. Understanding metal reactivity with water is crucial for applications like plumbing. Section 8. Hard water versus soft water. A tale of two waters. Water in nature is not pure. It often contains dissolved minerals. Water can be classified as hard or soft. Hard water has high concentrations of calcium and magnesium. Hard water can cause limescale deposits. Soft water has low concentrations of these minerals. Soft water is preferred for domestic use. Section 9. Softening hard water. Making water better. Hard water can be a nuisance, but there are several methods to soften it. One common method is ion exchange softening. This involves passing hard water through a resin column. The resulting water is softened because sodium ions do not form limescale. Another method is using a water softener unit. These units require regular maintenance, like adding salt. Section 10. Water's wonders. A recap. Water is an amazing substance that plays a vital role in our lives and the environment. Its ability to dissolve a wide range of substances makes it the universal solvent. We learned about solutions, where a solute dissolves evenly in a solvent, and explored the differences between saturated, unsaturated, and supersaturated solutions. We also discovered that not all mixtures involving water are solutions, with suspensions and colloids showcasing the diverse ways substances can interact with water. Water of crystallization, hidden within the structure of some crystals, highlights the surprising roles water can play. The reactions of metals with water, ranging from explosive to non-existent, underscore the importance of understanding chemical reactivity. Finally, we delved into the world of hard and soft water, learning about the effects of dissolved minerals and the methods to soften hard water. Water is truly a remarkable substance, and understanding its properties is essential for appreciating its significance in our world.